Alrighty, Algebra 1. We are going to go over now examples 4 and 5 in your note sheet. We skipped example 2 and 3, but I'll do those in an optional video at the end. So let's read through this real world example. Again, we're learning about factored form, standard form, and how they're connected to the graphs. So Jazir jumped off the diving board into the pool. He reached a maximum height. Ooh, I've got some key words in here. So I'm going to underline maximum height. Ooh, what does that word maximum mean when I'm talking about a parabola? Let's see, if you jump off of a diving board into the pool, that maximum is going to be the vertex. All right, maximum of 9 feet above the water. His jump is modeled by the equation. Ooh, and this is in factored form. All right, this is in factored form because we have multiplication. We have -1, and this negative is the same thing as -1. That's your a value, times x minus 5 times x plus 1. All right, those are all being multiplied. That is in factored form, where g of x, or y, is the height above water, and x is the time in seconds. So time in feet. So if I'm looking at this is my seconds, and this is my feet. All right. Time in seconds from the jump. So 0 seconds is when he jumped. All right, so let's take a look at factored form. Looking at this, I know that this right here, this a value, since a is -1, I know that this is going to be concave. What? Is it going to be concave up or concave down? Concave down, because it's negative like a frown. So my parabola is going to be upside down with a maximum of 9 feet. All right, let's see what else we know from this equation. From factored form, each of these factors shows me one of the, let's take a look at our notes. Factored form shows us the x-intercepts, the zeros, the roots. All right, so let's take a look. The x-intercept from this factor is going to be 5, because 5 minus 5 will give you 0. All right, so I'm going to have x-intercepts. Remember, that's the same thing as roots, 0, solutions. X-intercept is going to be at 5, 0. And over here, this x-intercept, what number will make this factor 0? It's -1. -1 plus 1 is going to give you 0. It's always going to be the opposite of the signs you see here. All right, so we know that it's going to be concave down, and we know that these create these x-intercepts. So I'm going to plot one at -1 and one at +5. Now, I know that this is at -1 and this is at +5, my two x-intercepts. I don't know where my y-intercept is, but I can tell that if I put it in standard form. So we'll do that in just a second. All right. Now, it says that there's going to be a maximum of 9 feet. I'm not sure where to put it, but I do know that parabolas are symmetrical. All right. If they're symmetrical, that means this vertex has got to be halfway between these two x-intercepts. So if I find the middle of that, I can go right into the middle. I know that that's where my axis of symmetry is going to be, because that's halfway between. So the vertex has to be halfway between, and we know that that maximum height is at 9 feet. So I'm going to go halfway and then go up to 9 feet. So there's going to be my vertex. So I almost have my whole graph now, except for my y-intercept. That y-intercept is going to be really, really important. It's somewhere over here. I just don't know exactly where it is. I can find it by putting this equation into standard form to get that y-intercept. So let's give that a go. I'm going to use the area model again. I'm going to multiply these and then distribute the 1 at the end. So let's go ahead and do that. I'm going to make an area model. It's going to be 2 by 2 because we have two terms, x minus 5 and x plus 1. Remember, x times x gives you x squared. X times -5 gives you -5x. X times 1 gives you 1x. And 1 times -5 gives you -5. So here is my start of standard form. Remember, we have to look for like terms. These are like terms, so we can add those together. I still have to do this -1, so I'm going to put that over here for right now. And in here, I have x squared. I combine these. I get -4x, because -5 plus 1 gives me -4, minus 5. My last step here, I've got to take that negative and distribute it into all 3 terms. So my standard form equation, when I write this out, I'm going to actually write it up here. Y equals negative times x squared is -x squared. Negative times a negative gives you a positive 4x. Negative times a negative gives you a positive 5. Now remember, that y-intercept comes from right here, that c value in your equation. That c value in your equation. So I'm going to take this. There's our y-intercept right here at 5. 0, 1, 2, 3, 4, 5. And if I want to, I can take this and use my axis of symmetry to reflect it over to the other side because it has a nice symmetrical parabola. So here is my beautiful parabola. So you take a look here. So Ja jumped off the diving board and into the water. Off the diving board and into the water. All right, here's our seconds and here is our feet. Here's our parabola. So now we're going to answer these questions about Ja. How high was the diving board? All right, he was on the diving board at 0 seconds. So I'm going to go to 0 seconds. The diving board's located right here. And then he jumped up and into the water. All right, so this right here, the diving board was 5 feet high. And I got that from the y-intercept. Because the y-intercept at 0 seconds, that's when he was on the diving board. So the diving board was 5 feet above the water. At what time did Ja enter the water? All right, high, that shows me that I'm going to use a y value. But here, this says time. All right, time means I'm going to find an x value. All right, at what time did Ja enter the water? Remember, the water's down here, all right, because this is how high above water. So he enters the water right here at 5 seconds. All right, so that was 5 seconds, and I can see that that is my second x-intercept right here. And then he goes under the water. That's why there's going to be negative feet here. He's going under the water. All right. At what time did Ja reach his maximum height? All right, let's take a look. Maximum means vertex. Since maximum means vertex, I take about that vertex. That vertex is at 2, 9. And this says time. So I want the x value. Time means x value. So that is at 2 seconds. 2 seconds after he jumped off the diving board, he reached his maximum height of 9 feet in the air. So we would do 2 seconds, and we used the vertex, or the maximum point for that. Name one input that does not make sense in context. All right, let's think about this. Input. Input means x values. What kind of time does not make sense in context? Oh, we can't have negative time. So if I take a look, this part of the graph over here does not make sense. So I'm going to choose -1 because he was probably still standing up here. So this part makes the most sense. We don't have negative time in this context. So I'm going to say -1 seconds. And one output that does not make sense in this context. All right, let's think. Output is our y values. Output is our y values. So I'm going to go to my graph with y values. All right, we go as high as 9, and then we can also go under the water. So one output that doesn't make sense might be something like 10 or 11, because he didn't go that high. There's no graph up there. All right, another output that might not make sense might be -30, because I don't think our pool is going to be 30 feet deep. But I'm going to stick with 10 feet in the air, because he didn't jump that high. He only jumped a maximum of 9 feet. All right, so that was our real world example. We're gonna do 2 more to help you with this work. All right. Remember, you can always pause the video, rewind, skip forward, do whatever you need to do to match your learning speed. All right, let's take a look at example number 5. We want to know, what form is this in? Is it factored or standard? And what do we know about the graph? The same thing for number 6. Is it factored or standard? And what do we know about this graph? All right, so just go ahead and analyze those two and think, which one of these is in factored form and which one of these is in standard form? All righty. So this one right here is actually in factored form. I know it's kind of tricky because we normally see 2 sets of parentheses, but this one, it only has 1 set of parentheses, and that's okay because factored just means multiplication, and there's still multiplication right here, even though we can't see it. All right, if 2 things are next to each other, that means it's being multiplied. All right, so another way this function could look is y equals negative x with parentheses times x minus 10. Or another way you could look at it, negative x is the same thing as we could have a negative out here, and we could also have x minus 0 or x plus 0. All right, if you have a 0 there, that means that it's the same thing as just x or just x. So all of these are the same thing. So since this is in factored form, let's go back to our notes. Factored form, we know that the a value is going to tell us our concavity, and we know that our factored form is going to show us our x-intercepts, or another word for that is zeros or roots or solutions. So let's look at each factor. This one right here. Oh, first I'm going to look at the a value. This a value is negative, which means it's going to be concave down. So a is negative, all right, which means we have concave down. We have concave down. All right, we've got an upside down parabola. All right. And then we also know that factored form shows us our x-intercepts from each of these. So what value will make this 0? X equals 0 is going to turn this into 0. So one x-intercept, 1, 0 is going to be 0, 0. And what's going to turn this into 0? Well, 10 minus 10 gives you 0. All right, so 10, 0 is going to be our 2 x-intercepts. So we'll have 1 at 0, we'll have 1 at 10, and then we know it's going to be concave down. So I'm going to go upside down, boop, doop, to see what that graph will look like. All right, to see what that graph would look like. To put this one in standard form, the area model is going to look a little bit different. Because this doesn't have 2 terms. It only has 1 term. So this has 1 term, this has 2. So to put this into standard form, my box, instead of being a 2 by 2 box, is only going to be a 1 by 2 box. The factor that only has 1 term is going to go on the side that only has 1. And then the factor that has 2 terms are going to go here. So I can still put it in standard form. Negative x times x gives you negative x squared. Negative x times negative 10 gives you positive 10x. So in standard form, you have y equals negative x squared plus 10x. And then there's no c value. That y-intercept is not there because it's just a plus 0, which is, you can tell right there. Last one. Remember, you can pause and go back, rewind whenever you would like to. Example number 6. All right. This one right here, it's not in factored form because I don't see multiplication. I see addition and subtraction. So this one is in standard form. What do we know about the graph? Let's analyze it. Is our a value positive or negative? It's positive. So since we have a positive a value, this one's going to be concave up. And then we also know our y-intercept. Remember, our y-intercept is always going to be that c value, that constant term right there. So our y-intercept, whoopsies, y-intercept is going to be 0, -2. All right, so there's not too much we know about this graph. You might be asking now, how could we take standard form and put it back into factored form? That is something that you guys are going to learn in the next couple weeks. That's called factoring. All right, so keep looking forward to these next coming weeks and we will learn how to do that. If you need more examples, I'm going to do examples 2 and 3 in a future video if you are interested. Otherwise, good luck with your work this week. See you later, guys.